The corona is the outer atmosphere of the Sun. The material in the corona is extremely hot but very tenuous plasma. The temperature in the corona is more than 1,000,000 degrees, hotter than the temperature at the Sun's surface, which is around 5,500 degrees Celsius, 9,940 degrees Fahrenheit or 5,780 kelvins. The enhanced spatial and temporal resolution of the Solar Observation Satellite, OSIRIS, has made it possible to study the structures adequately. IRIS pictures are capable of resolving information of transition region loops and detect pockets of superhot plasma. The pictures analyze the actions and temperatures of ions within the loops through the light they emit, read as spectral lines that function as chemical fingerprints. The heavier ions, such as silicon, are preferentially heated in both the solar wind and in the transition region between the Sun's chromosphere and corona. The images discovered hotspot spectra where the lines were broadened by thermal and Doppler effects. The researchers studied components of the mechanism, how the energy gets out of the magnetic field, and then how it actually heats the plasma. The transition area is only about 10,000 degrees Fahrenheit, but convection on the Sun's surface affects the loops, twisting and braiding. The thin magnetic strands that comprise them, and provides energy to the magnetic fields that ultimately heat the plasma. The magnetic fields of the plasma strands break and reconnect at braiding sites into lower energy states, releasing stored magnetic energy. The plasma becomes superheated. The regions in the little loop structures reconnected and measured the emission lines from the ions, chiefly silicon and oxygen. It was then discovered that spectral lines of the silicon ions were much broader than the oxygen. Despite false fears like crop loss, famine or volcanic eruptions, scientists say that the Earth is safe. This is just the solar minimum 11-year period when the activity of the Sun reduces and the cosmic rays enter our planet's atmosphere. Excess cosmic rays pose a health hazard to astronauts and polar travelers, affect the electrochemistry of Earth's upper atmosphere, and may help trigger lightning. The global warming trend in the last decades cannot be explained in terms of solar activity because there has not been any trend in solar activity.